In 7.1, we're learning about multivariable functions. I know it's a very fancy sounding name, but it's, well, first of all, you'll see it's very simple to math. But meanwhile, the whole concept of multivariable is an important concept in life because life is multivariable. If you want to know how much, if you have a bacteria in a petri dish and you want to know how much it's going to multiply, well, it depends on how much time you leave it in the dish. It depends on what the temperature was in the place where you left the dish. It depends on maybe the humidity in the room. All these things will affect. Each of these are factors, variable. Get it? Because they change. And depending on, and there are biologists who make formulas to figure out. Depending, you can just plug in the amount of time, the temperature, and so on and so forth. If you have a factory that makes bicycle tires and tennis balls, well, the cost is going to be a function of how many bicycle tires you make per day and how many tennis balls you make per day. There may be other things also involved in the costs. And that's life. Life has many, many factors to it. And we have formulas that figure out all those things. Meanwhile, let's just show you how to deal with some simple multivariable functions. Let's start with this top one. So f of x comma y, instead of writing f of x equals something, we write f of x comma y, because those are two variables. So in this function I just made up, f of x comma y is equal to x plus y squared. So let's say, for example, I put in f of 1 comma 2. I just take the first number, stick it right there, take the second number, square it, add the two together, and I get 5. Notice that when I switch the variables, instead of 1 comma 2, I switch it to 2 comma 1. Notice I get a different answer. I'm going to get 2 plus 1 squared because 2 is the x value and 1 is the y value, and now my answer is 3. So this is not, I don't know, commutative. So I don't know if commutative is the right word, but it's not necessarily switchable. That's why they call them ordered pairs. Let's look at this next function. This next function is kind of interesting, where we have an integral from 0 to t of x to the r power dx. Now I don't know what power it is. I don't know how high t is. But the value of this integral, now this is a definite integral, which means ultimately it's just going to equal a number. It's not going to equal some function. It's going to equal a number. Well, we need to plug in values of r and t. So let's take f of 1 comma 2. That means r is going to be 1 and t is going to be 2. So the integral is going to be the integral from 0 to 2 of x to the 1 power dx, which is just x squared over 2 evaluated between 0 and 2. And that's just... that just winds up being 4 divided by 2, which is 2. If I switch the r and the t, if I switch it to 2 comma 1, now it becomes the integral from 0 to 1 of x squared dx. And now the integral of x squared, as you know, is x cubed over 3. We're evaluating between 0 and 1, so our final answer is 1/3. Here's a 3-variable function. Why not? You could, I mean, in theory, you could have a 20-variable function, but we're not going to deal with such, you know. In this class, we're going to pretty much cut it off at 3 for the most part. And g of x comma y comma z is equal to x plus 2y plus z squared. And let's try 1, 2, 3. G of 1 comma 2 comma 3 is 1 plus 2 times 2 plus 3 squared, which is 1 plus 4 plus 9, which is 14.